Hi friends, welcome to my channel. Let's have a look at a new problem, that is 2348, number of zero-filled subarrays. So in this problem, we're going to share a solution based on simple counting. So the problem asks us to return the number of subarrays filled with 0. In other words, the subarrays contains elements only 0. So in example 1, so the return is 6. So you see here are 2 zeros, here are 2 zeros. And in example 2, so here are 3 zeros, here are 2 zeros, and the return is none. And in example 3, there's no zeros, so the return is 0. And the constraints on this problem are mainly the length. So the length is bounded above by 10 to the power 5. So the range of each number in the nums array is between negative 10 to the power 9 to positive 10 to the power 9. So with that said, let's look at the solution here. So actually, this problem is a rather straightforward problem. So the main observation is that if there are k continuous 0 elements, so their contribution to the final counting is this expression. So k plus 1 times k divided by 2. So this here is a simple explanation. So assume we have 3 consecutive zeros. Then the subarray of length 1 is 3, right? So the subarray of length 2 is 3 minus 1, that is 2. And the subarray of length 3 is 1. So in total, it's just a sum, 1 plus 2 plus 3. That is this expression. So you can consider the general case. So here we're going to write a code based on the following procedure. So we just need a linear traversal, and then we finding the contiguous zeros and then increment the count. So let's do the code directly. So first I'm going to make some initialization. So first we want to track the length of nums, and also we want to initialize a result variable to do the count. At the very beginning, so we have n zeros is 0. So then we want to find the count of zeros in the consecutive pieces. Then we add the corresponding contributions to the final result. So this is just a linear traversal. So for y in enumerate nums, then we want to check if y is not 0. In other words, we're going to recount. But before we do the recount, let's first increment the result by, say, n zeros plus 1 times n zeros divided by 2. So because we initialize n zeros by 0, so this, if in the beginning, this may just add 0. So this just makes the writing or the format a little bit cleaner. So with that said, let's consider then we need to reset the zeros equals to 0. So n zeros is a count of zeros in each consecutive pieces. And then in the other case, then we're going to increment the n zeros by 1. And here we also need to consider a special case. So if there are many zeros ending at the tail, then we want to do a check so that we do not miss a part in the counting. So that is when I equals n minus 1. So we should increment the result. So that's it for this problem. Then we're going to do the return. Just return the count. So with that said, let's do a special case check. It passes a special case. Now let's do a generic case check. Yeah, it passes the generic case. So this solution is a linear solution, obviously. So with that said, I guess that's about it for this problem. Thank you very much.